Hey everyone, ready for another deep dive?
Always.
Awesome. Today, we're going to explore something, well, pretty mind-bending. The connection between evolution and artificial intelligence. We've
Hmm.
got this study guide we're looking at, and it dives into how we can use the principles of evolution to make AI better, more robust and reliable, you know?
It is fascinating how nature kind of offers these ready-made solutions to, well, problems we're still grappling with in AI.
Exactly. So
Yeah.
this study guide, it kicks off with this idea of a two-level learning paradigm.
Okay.
And it argues that slower, like long-term processes, things like evolution, they actually shape the playing field for faster, more adaptive systems.
Right. And that's not limited to like just biological evolution either. Think about corporations, right? They might have their own internal strategies and all that,
Right.
but ultimately it's market forces that really decide who makes it. Survival of the fittest, even in the business world.
So it's like saying evolution sets the ground rules, and then companies, they have to play the game within those rules.
Precisely. And you can see the same thing in human behavior, too.
Okay. Yeah.
The experience of pain, for example, that teaches us to avoid things that are harmful to us.
Right.
It's two-level learning in action.
Oh, that's a great point. It's like that time I ate that entire pint of ice cream in one sitting. Never again.
Hmm.
But seriously, the study guide then goes in, takes a really interesting turn. It compares markets to centralized planning as, mechanisms for optimization.
Yeah, the author's argument is that markets act as these weighing machines for different proposals. You know, they efficiently process information from everyone involved and use it to determine prices and figure out where resources should go.
But then they bring up these tech companies like Amazon and Google. They're using algorithms for like logistics and resource allocation. Isn't that kind of more like a planned economy?
Well, yeah, that's the debate, right? I mean, are these companies, like with their super intricate internal systems, are they moving away from free market principles? And if so, what does that mean long term? It's definitely something to think about.
Definitely. And here's another point they make. They argue that corporations, unlike biological organisms, they're actually terrible at replicating themselves effectively.
Yeah, it does seem counterintuitive at first. I mean, they try to expand, they buy other companies, they try to, build on their success.
But they seem to miss that secret sauce somehow.
Right.
It's like they lack the DNA equivalent for true replication.
Mhm.
And the feedback mechanisms they do have, like bankruptcy, those are so blunt.
Yeah, bankruptcy basically just tells you that something went wrong, but it doesn't tell you why or how to fix it. It's like trying to solve a puzzle with only half the pieces.
And this leads to a bigger challenge, which they call the credit assignment problem. It's basically the difficulty of figuring out, which specific actions led to a certain outcome, especially in really complex systems.
Right. And this problem, it comes up in AI too.
Mm.
Like, imagine you're training an algorithm.
Right.
You need to give it clear feedback on whether it's doing the right thing or the wrong thing. But if you can't accurately assign credit for specific actions, it makes it really hard to, you know, optimize it properly.
So it's like me trying to figure out which of my daily habits are helping me reach my fitness goals, but all I have is my weight on the scale. I have no idea what's actually working.
Precisely. And the study guide talks about two approaches dealing with this: black box and white box optimization.
Okay, break those down for me. What's the difference?
Sure. So black box methods, they treat systems as, well, kind of opaque. You put in inputs, you observe the outputs, but you don't really understand what's happening inside.
Mm.
It's like evolutionary algorithms. They
Mm.
test tons of variations and just pick the best one, but they don't really know why it works.
So it's all about results, not understanding the process.
Right. White box methods, on the other hand, they try to understand the system's inner workings. Think of things like model-based reinforcement learning. You build a model of the environment and use that to figure out the impact of different actions.
So it's like having a blueprint for the system.
Exactly. White box approaches, they allow for better credit assignment, which leads to more efficient optimization.
Oh, okay.
But there's a trade-off. They take a lot more processing power.
It's like choosing between a fast but sloppy solution and a slower but accurate one.
Yeah.
Tough choice. But get this. They argue that pain is actually a form of ground truth loss.
It's a fascinating concept. I mean,
Yeah.
pain, it's really evolution's way of providing this immediate negative feedback, right?
Yeah.
It keeps us grounded in reality and keeps us from making choices that could hurt us.
That makes a lot of sense. It's like when I was a kid, I tried to touch a hot stove. Instant feedback.
Exactly.
But why is pain so, well, painful?
Well, think about it. If it were just a mild sensation, we could easily ignore it and end up hurting ourselves even worse.
Hmm.
Pain forces us to pay attention and learn from our mistakes.
So pain is like that super strict teacher who gives you pop quizzes every day, but then you end up acing the final exam because of it.
You could say that.
I guess pain has its perks, but the author takes this idea even further. They apply it to the mental realm too, like with willpower and procrastination.
Right.
Now, this is where it gets really interesting. How does pain relate to putting off, that mountain of laundry?
Well, the author suggests that fatigue, boredom, even that urge to procrastinate, those could be signals from our brain telling us to switch gears,
Hmm.
take a break.
Okay.
It's like our brain saying, hey, you've been working on this for too long. Time to explore other opportunities.
So my brain's actually doing me a favor when I decide to binge watch that new show instead of finishing that report.
Maybe it's a different way of framing those experiences.
It is.
Maybe procrastination isn't always a bad thing, but rather a signal to consider other possibilities.
That's a real mind shift. And on that note, I think we should take a pause before we dive into the next part of this deep dive.
That sounds good.
We still have a lot to uncover about how evolution can inform AI development.
Looking forward to it.
Me too.
Welcome back. Before the break, we were talking about, um, how maybe procrastination isn't always a bad thing.
Right, like maybe it's our brain trying to protect us from, I don't know, mental overexertion, sort of like how pain protects us physically.
Exactly.
But the study guide, it goes even further with this idea. It brings up this thing called the Lisp curse.
Oh, yeah, the list curse. This is where things get really interesting.
Yeah.
It basically says that really powerful tools, well, sometimes they can lead to systems that are super efficient, but also really hard for anyone else to understand or copy.
Kind of like a super complicated recipe that only like a master chef can follow.
Exactly. And the author uses this example of Donald Knuth.
Okay.
He's this brilliant computer scientist famous for creating these super efficient programs, but they're often, well, really hard to understand. His work shows the power of, his intellect. But it's also kind of a cautionary tale, I guess.
So even genius level planning, it has its limits.
Yeah, especially when it comes to building systems that can actually evolve and adapt over time.
Right.
And that brings us back to the author's main argument, I think. Maybe instead of trying to create perfectly planned AI, we should be thinking about a more, I don't know, more evolutionary approach.
That's a pretty radical idea. What would that even look like?
Well, instead of designing AI systems from the top down,
Hmm.
we could, create environments where AI can learn and adapt on its own, responding to like unexpected challenges without needing humans to step in all the time.
So more like setting up a digital ecosystem and letting AI evolve within those boundaries.
Yeah, something like that.
That's pretty wild.
It is. But think about how evolution works in nature. It's messy, it's iterative, it's all about trial and error and variation and selection. And through that whole process, nature has come up with some incredibly complex and resilient systems.
It makes you wonder what kind of AI solutions we might find if we took a similar approach. Solutions we can't even imagine right now.
Right. And it really challenges our assumptions about what it means to, like, design and control intelligent systems.
It does.
But, the study guide also brings up this point about corporations that despite their best efforts, they often struggle to adapt effectively.
Yeah, they don't have that clear feedback mechanism that you see in biological evolution, like it's survival of the fittest in nature.
Yeah.
But companies, they can keep going for years even when they're making bad decisions.
Exactly. And even when a company does fail, it's often hard to say exactly what went wrong. Was it like one big mistake, or was it a bunch of smaller ones? That credit assignment problem strikes again.
Right. It's like a detective trying to solve a case with only, a few scattered clues. So how do we create better feedback mechanisms for, I guess, for organizations?
Well, it might mean making decision-making more transparent, or coming up with systems that can actually track the effects of different choices. Basically, closing that feedback loop so organizations can, learn and adapt more like living systems do.
That makes sense. And it seems like that same principle could apply to AI development as well.
Absolutely.
Speaking of feedback, the study guide goes deep on this idea of pain as a ground truth loss.
Yeah, it's such a powerful concept. I mean, pain is probably the most fundamental feedback mechanism we have. It tells us right away, when something's wrong and, pushes us to do something about it.
It's like evolution's built-in alarm system, right? Like
Yeah,
blaring the sirens when we stray too far from what's good for us.
exactly.
But, the author takes this idea even further, extending it to the mental realm as well.
Right. Things like fatigue, boredom, even that urge to procrastinate, they could be our brain telling us to, maybe switch gears or take a break.
So maybe those feelings aren't like signs of weakness, but more like a form of mental self-preservation.
Yeah, like our brain hitting the pause button to prevent burnout or something.
Exactly.
It really shows how important it is to pay attention to those internal signals.
It does.
And, the study guide also introduces this concept of meta-learning.
Meta-learning. Okay, that sounds interesting. What's that about?
It's essentially learning how to learn.
Okay.
It's about developing systems that can, not only master specific tasks, but also get better at learning new things in general. Think about how we learn as humans.
Mm.
We're constantly tweaking our learning strategies based on what works and what doesn't.
Right, like figuring out which study techniques work best for you or how to approach a new problem based on, what worked in the past.
Exactly. And the author argues that we need to build AI systems that can do the same thing, systems that can actually adjust their own learning algorithms based on the feedback they get.
So that could lead to AI that's way more flexible and adaptable than anything we have now.
Exactly. AI that can not only solve specific problems, but also continuously evolve and get better at tackling new challenges. It's a crucial step toward creating truly intelligent systems.
Yeah.
But to understand how systems evolve, we need to understand the forces that drive that change.
And that's where the price equation comes in, right?
Yes. The price equation. It's a fundamental idea in evolutionary biology. It describes how the average trait value in a population changes over time due to, things like selection, mutation, random drift.
So it's basically a mathematical way of explaining how evolution works.
Exactly. And the author applies this equation to analyze the evolution of corporations, which is really interesting because, well, companies aren't exactly like biological organisms, are they?
Right. They don't reproduce in the same way, and they're dealing with different kinds of pressures. So how can we use a biological model to understand how corporations evolve?
It's about looking for those underlying principles that drive change in any complex system. The price equation gives us a framework for understanding how, any system, biological or not, evolves over time.
So it's like a universal language for describing change.
Yeah, I could say that.
That's pretty cool. But things get really trippy when the study guide starts talking about the evolution of evolution.
I know, right? It's mind-blowing.
Yeah.
The idea is that even the process of evolution itself can evolve over time. Like the mechanisms of variation and selection can change, which can lead to some pretty unexpected results.
It's like saying the rules of the game can change while the game is being played.
Exactly.
How can we even predict the future of evolution if the rules are always in flux?
Well, we can't. That's the point. The future of evolution is likely to be far more complex and unpredictable than we can even imagine. And that applies to AI too. As AI systems get more advanced, they could actually change the nature of intelligence itself.
Wow. That's both exciting and a little scary, right? Like we're stepping into, I don't know, uncharted territory
Mm,
where the map is being drawn as we explore it.
exactly. But it also means that the possibilities are truly endless. Before we move on, though, there's one more concept I want to touch on. Goodhart's Law.
Goodhart's Law, what's that? It sounds kind of ominous.
It basically states that when a measure becomes a target, it ceases to be a good measure. In other words, if we focus too much on optimizing for a specific metric, we could end up distorting the very thing we're trying to measure.
I see. Like when a company gets obsessed with short-term profits
Yeah.
and ends up, sacrificing long-term growth and sustainability.
Exactly. Or in AI, when an algorithm gets trained on a specific data set, it might become really good at performing on that data set, but then it fails to generalize to new data. It's the danger of over-optimization.
So we need to be careful not to get tunnel vision when we're designing AI systems. It's not just about optimizing for specific metrics. It's also about considering the bigger picture, the wider impact of our choices.
Exactly. We need to create AI that's not just intelligent, but also wise. And that's a challenge that requires us to think deeply about the values we want to embed in our AI systems.
Yeah,
It's a conversation we need to have now, before it's too late.
that's some heavy stuff. But it's also really thought-provoking. I'm ready to hear more. Let's take another quick break and then wrap up this deep dive into evolution as a backstop for reinforcement learning. I can't wait to hear your final thoughts and takeaways.
That's good. We'll be right back.
Okay, we're back. Ready to wrap up our deep dive into evolution as a backstop for reinforcement learning. Feels like we've covered a ton.
Yeah, we have from two-level learning, the list curse, all the way to Goodhart's law.
So much. But for those listening who might be thinking, whoa, too much info, what are some of the big takeaways here?
I think one of the most important things is, well, accepting that there's going to be uncertainty. We can't know exactly how AI will evolve, but we can at least create environments where it can do so safely.
So it's more like we're setting the stage, not writing the whole script.
Yeah, exactly. Like gardeners.
Yeah.
We can provide the right conditions, but we don't control exactly what'll grow.
Makes sense. But even with a garden, you got to watch out for problems, right?
Oh, absolutely. That's where Goodhart's law comes in, right? We need to make sure we're not getting so focused on one thing that we miss the bigger picture.
Right, right. Not just going for the tallest sunflower, but making sure the whole garden's healthy.
Exactly. And another key thing is feedback. Whether it's companies or AI, feedback is how they learn and adapt.
Hmm. So we got to find ways to make sure that feedback loop is working, right? So our systems can get better and more resilient.
Absolutely.
Yeah.
Maybe even borrow some ideas from evolution itself.
Oh, interesting. You mean changing how we think about AI development altogether, not just trying to create the perfect system from scratch.
Exactly. What if instead of pure optimization, it's more like guided evolution?
So give the AI some boundaries, but then let it figure things out within those limits.
Right. Imagine a bunch of different AI agents all competing and working together within, like, a carefully designed environment.
And out of that whole process, who knows, maybe we get AI that's tougher, smarter, maybe even more creative than anything we could have come up with on our own.
Exactly. It's a big, bold vision for the future of AI, but I think it's worth considering. After all, evolution's had billions of years to work on this planet. Maybe we should pay attention.
I like that. So, everyone listening, remember, embrace the unknown, make sure those feedback loops are working, and never underestimate the power of evolution. Who knows what amazing AI we could create if we let go a little and embrace that unknown. It's been great exploring these ideas with you.
Likewise. And to everyone out there, keep learning, keep asking those questions, and until next time, keep exploring.